Yeah, try the next problem. A body slides down along the rough inclined plane with a constant velocity u. If it is projected along the inclined plane with the same velocity, then find the stopping distance. Stopping distance means final velocity 0. So the distance traveled by the body before coming to rest, the distance is called as a stopping distance. Final velocity 0. And initial velocity is u. So how the body moving now? A body slides down initially. The body slides down along the rough inclined plane. What tell me now? With a constant velocity. Now case 1, first case, how the body moving, tell me now. So in the first case, how the body moving? How the body moving now here? Up or down? Case 1, so body slides down. What tell me now here? With constant velocity they given. With constant velocity. Constant velocity. Constant velocity means how the acceleration. How much the acceleration for a body, if the body with a constant velocity. Acceleration is what, tell me now? Rate of change of velocity. Constant velocity means constant derivative. 0. So constant velocity means how the acceleration? 0. So that means what, tell me now here? We have what is the acceleration down the plane? Acceleration down, which will be equal to what, tell me now here? That is g into what we'll get now here? Sine theta minus mu cos theta. They're saying that body moving the constant velocity. Constant velocity means acceleration of a body is how much? 0. If it is 0, so you can tell me now here, that is g into we have a sine theta minus mu cos theta. So we'll come it as what, tell me now? Equate now sine theta, which will be equated to what, tell me now? Mu cos theta. From this, mu value will come to be a how much now? Mu value will come to be a tan theta. So that means here this is the condition. Mu is tan theta. This is a case 1. Second case, what they are saying now? Now, if it is projected up now, projected up along the same inclined plane with the same velocity, then how much the distance traveled by the body before coming to rest? Second case. How the body moving now here in the second case? Right. So here body moving up the plane. Body moving up the inclined plane. So in this case, you tell me now what we can say now. What is the initial velocity of a body given as a u? And we need to get the stopping distance. And final velocity of a body is how much? 0. Now acceleration, body moving up now. So how much the acceleration you tell me now? Which is equal to a up now, that is minus g into sine theta plus mu cos theta. Next, so displacement we need to calculate how much the distance will travel. Yeah, tell me now in this case, and which formula I can use now here? That is v squared minus u square, which is equal to 2as na. Yes, final velocity 0 minus initial velocity u square, which is equal to 2 into, this is g into sine theta plus mu cos theta. Sine theta plus mu cos theta into s. Minus will get cancelled. How much will get now? So it will come to be a what? Tell me now. This is u square equal to 2gs into sine theta plus mu cos theta. Sine theta plus mu cos theta. Right. Now, so we have seen the relation now. They given mu is equal to tan theta. So we use this relation here. Mu is equal to tan theta. Now from this, that is u square, which is equal to 2gs into what? Tell me now, sine theta. Yes, plus what? Tell me now, mu is equal to tan theta into cos theta. So tan means sine by cos will get cancelled. Then will come to be what? Tell me now here, u square, which is equal to 2gs into what? Tell me now, 2 sine theta. So from this we need to get the s value. So s will come to be what? Tell me now, u square by 4g sine theta. This is the distance traveled by the body before stopping.